To welcome our co-founder and CTO, Sasha.
Right, folks, do you hear me? I think this is the last presentation before the happy hour, right? Or almost the last presentation. That's why I've prepared a 55-slide deck that's going to walk you through every single feature we're going to release in 2024 with the most level of detail possible. I'm just kidding, folks, obviously. I'm Sasha, CTO, co-founder of Teleport, and I've never used this clicker before, so let me see if that works. Perfect. I'm going to walk you through what's coming in 2024. And first of all, I'd like to thank everyone who has demoed today, who has participated in all conversations. And when I'm talking to folks, I'm always humbled when I ask folks, well, do you live in the Bay Area? They're in no, I flew in from Dallas. It's like, wow, that's a long flight. And you came in just, you've been around the area? No, they're like, no, I just flew in for Teleport. It's like, wow, we are doing something exciting enough for people to take flight all the way to Teleport. And just very exciting to be at that spot. So I'd like to thank you all for that. And I'd like to talk about what's coming in 2023 because I'm impatient. I know you all folks are impatient as well, but some of the features I'll demo are already scheduled for release in 2023, not because we are trying to move fast and sometimes, unfortunately, break things, but we think there is a sense of urgency of the problems that we need to address together. And let's discuss the primary challenges that first motivated us to develop and expedite some of those features in 2023. And then I will do an attempt at the live demo. So hopefully that will work. But let's first talk about what's happening. So let's look at the situation we're in. And for the past 5 years, we have been observing a shift. 5 years ago, maybe 6 years ago, if someone is trying to hack someone, they're probably trying to plant some type of malware on someone's computer or find vulnerability and find some network weakness and exploit it through some unpatched CVE on infrastructure. Zero Trust has been changing all that over time consistently. And adversaries' behavior is also changing. And you can observe in the past 5 years, if 5 years ago, 6 years ago, most of the breaches were mostly malware type, most of the breaches right now are what's called malware-free. What does it mean? That folks are trying to identify and compromise valid user credentials, whatever they are. And not only that, by 2022, that increase that led to this dramatic increase of malware-free cyber attacks from about 38% to 72%. And if you look at the 2022 alone, what's called cloud-conscious actors, basically folks trying to hack your cloud, primarily focused on exploiting your identity or identity of high-value targets of your infrastructure. Because, let's be honest, if they steal the crown jewel, primary key, private key from your Jenkins that is unpatched, or an IT administrator who manages your Oxy account, it's game over. They can do a lot of damage without you being able to identify it because inside the system, they look exactly like any valid account would look like. Their behavior might be slightly different, but you're working with adversaries there that also understand how to cloak their behavior in a way that will not raise alerts. And their job is to stay in your system for as long as possible without you realizing that. So we're seeing that folks are playing web shells, reverse shells, after exploiting those apps, such public web servers, all those different types of attacks. Those new challenges that we're facing need us to focus we need to protect users and services with access to critical infra. Where do we start? We need to deploy defense in depth approach. First, we have to systematically reduce the attack surface. It means that engineers should request access only when they need it. And we need to eliminate shadow IT by making sure that every access request and review is granted, approved, and reviewed. with a tamper-proof audit log system, because again, if you're working with adversary, the first thing they're going to do, they're going to do some damage and hide their activity so you cannot discover it. And that means that every access request and access review not only should be granted and reviewed in a way that you can audit, but the audit itself should be tamper-proof and reviewed in the same way. In addition to that, we have to eliminate user errors by mandating periodic access reviews to the infrastructure. And we'll need to do all that without slowing things down. If you think about any sort of incident response, the perfect incident response, like from the security perspective in the vacuum, would be to shut everything down, right? Nothing works, no damage, but that's impossible. So we also have to make sure that all those measures don't slow your business down, and you can create a Byzantine system of requests and approvals in a way that will basically make the whole thing unusable. So all of those measures have to be deployed in a way that are native to your developers, because otherwise your developers in San Francisco are going to cross the street and will work for someone else, right? That's literally what we observed in some of the companies we worked. There was an office on Folsom Street. Across the street, there was Slack office, and if someone was not happy, they went to grab coffee, went to get an interview, and that's it. The second defense is to monitor for weak access patterns. Even if you deploy all those strong measures, folks will still ask for legacy use cases, for exceptions. Jenkins box needs long-standing privileges sometimes to deploy CI/CD jobs and run those systems. You may have legacy systems. You may not have everyone who received per session MFA. So those exceptions accumulate, and we think of them sometimes as, well, just an exception, right? But from the adversary perspective, that's going to be their primary target. They don't know about your state of mind, and they're not interested. All they need to find is the weakest link in the chain, and that's the only thing they're going to look for. So from your perspective, you have this exception that you will over time fix. From their perspective, perfect. They got exactly what they need, right? In one of those famous security books, Cryptography Engineering, there's a great analogy where you can build the strongest door, right? And that's one of the offices the security team has reviewed. There was strong door, there was lock, and then when security folks looked up, there was, those old school floors, ceilings that were not real, and the only thing they need to do is just to pop up that ceiling and go over that, ceiling that was not real. So that's exactly how any adversary would think. It means for you, the job, you have to make an exception. Sometimes you're under business pressure to deliver results, but you need to have a system to periodically review and systematically apply pressure and eliminate those weak access patterns. And finally, as your last resort, you have to respond. By standard statistics these days, you have about 84 minutes from the initial breach to response. That's how long it takes from an adversary to first gain foothold in your infrastructure, to pivot, and because they need to explore, find all those other weaknesses, and distribute their whatever malware, whatever software they're planting there, to as many points as possible, undetected. It means that your incident response should be instantaneous. That's why we have announced today, that was our launch of identity governance and security. Our access monitoring system helps you identify and eliminate weak access patterns. Our access requests, access lists, and access reviews help you to reduce the attack surface. And finally, we built identity locking as your last line of defense, where you can lock suspicious identities within seconds. And not only that, you can guarantee that any activity within your cluster going from those identities is immediately terminated. That's a really important part of incident response. Otherwise, you basically still have to look for that activity yourself. Hopefully, you've seen a deep dive of those features today done by Shane, our VP product. I'm not going to demo those today. If not, you can go to goteleport.com, identity-governance-security, and explore the video, tutorials, and demos that we have published there. So several years ago, we realized that we can't solve actually any of those access challenges without first going back to principles of computer science. And that's my favorite topic. That's what I like to think on long walks. Things that were done in the 70s, for example, like those famous Tiger teams that were tasked to build the most advanced access control systems for Multics and what happened since then. So, but let me demonstrate this problem for you. Let's say, let me ask you this question. Imagine you pick any person in your organization at random. If you manage a team, right, or if you're responsible for access management, I am, and you would have the following question stated to you. Can you tell me what systems that person has access to? Please raise your hand if you can deliver answer to that question within 84 minutes. One person. So that makes my presentation much simpler. I thought, there's going to be anyone raising their hand. So, okay, with 80% of confidence within a day, anyone who can answer that question today? All right, with 80% confidence, I'm seeing a couple of hands raised. So from the day, how long would it take you to get answer to that question? Let's say if we relax the time requirement, are you even capable of answering this question in your organization? Please raise your hand if you think you have tools to answer that question within your organization. 1, 2. To any degree, let's say like to any degree of confidence, that is to 80? 80%. 80%, all right. So that is the problem. Who has access to what? And the question, and why? And how would you the reason it's so important to have answer to that question is that what is the part of your incident response then, right? So if you think that identity has been compromised, you can't shut down the entire organization. You need to identify the instances, databases that could have been potentially accessed with potentially malicious software running there, and make sure no activity is happening there, at least from that identity and maybe from the rest of the organization, because again, this could be honeypots that have been installed there that are pretending to run some legitimate software and plant some exploits there to everyone else. And basically, we discovered that answering this question completely isn't possible today. There are two reasons for why it's not possible. The first reason is the fragmentation of access. Sometimes to define access control policy, you need to use YAML and RBAC, like in Kubernetes or Teleport. Sometimes you need to go back in time to JSON or with AWS IAM. Sometimes you need to connect your Postgres instance and run SQL queries. Sometimes you need to go to the file system and edit suitors files. Sometimes you need to go to CLinux, and sometimes you need to do more and more and more. And none of those tools are aware of each other. They don't know that they exist, and they need to cooperate in some way. So it means that organizations need a unified access system with full visibility and control of all user services and target resources. Without this, you have a shadow access problem, where you don't know, small exceptions accumulate, and they can lead to catastrophic effects. The second reason is lack of ability to model and test changes. This leads to what I named it, you tell me folks if it's a good name, a butterfly effect. So let's say we have a user Alice, and you made an honest mistake and added Alice to the group RSA instead of group SRE. Maybe just honest typo, maybe it's autocomplete that didn't work out. So a couple of things could happen. The first one is, Alice couldn't just get access to the SRE infrastructure. She needs to perform operations and maintenance. You'll get a support ticket, but maybe RSA is the private key material for your entire infrastructure. And you don't know, that's the problem. You don't know what the change in one side of the system and what kind of effects it will lead to. That's why I call it butterfly effects. And let me know, folks, if it's a good name or maybe it's a bad name. So that basically led us to create Teleport Access Graph, or as we started calling it, TAG. It is designed to address both of those challenges. With TAG, you can model, review, and query changes, detect and prevent access issues before they happen by using visual interface or SQL interface that we have built, and I will try to demo it today. Here's how TAG works. It discovers, imports, and keeps up to date all your users, all your cloud resources, all your groups. You can use automatic import by Teleport, or you can use API. Folks have been asking me when I've been demoing it today, how can I import my on-prem infrastructure? You can just use your discovery service and import your resources this way. But the important thing is everything is in one place, which is a graph database. And the second step, once you have this unified graph database structured in a certain way, you can review and query access using Visual Interface or SQL. Before jumping into the demo, let's review some of the tag foundational blocks. So there's going to be a little bit of computer science, folks. Let me know if you see that well. See that well? All right. So let's say each user or resource can belong to multiple user groups. Right? These groups can be native to Teleport or imported from your identity provider. You can create them through API. You could have multiple identity providers. Same goes about users, right? Users could be local. They could be robot users. They could be users coming from Okta or Azure AD or any other identity provider. So in this example, Ryan is a member, so that's where this relationship is coming, is a member of the devs user group. Just as with users, Teleport discovers, imports, and updates all computing resources and assigns those resources to multiple resource groups. Again, folks have been asking me in early demos how this assignment works. Is it a manual step? It doesn't have to be. Most of the time, you would assign each computing resource to a certain resource group automatically, deriving that from some metadata about the resource. You can imagine you have a resource Luna, which could be, for example, having a AWS tag, staging, and this tag will be automatically discovered, and tag will assign this resource to staging resource group. As the resource changes its metadata, it will be automatically removed from that resource group. So think about it as a dynamic system that updates as you update your infrastructure, because if your infrastructure is dynamic, your system has to be as dynamic as your infrastructure. And finally, that's the last bit of computer science for today. To grant someone access, there must be an allowed path from the user to an action to the resource group to the resource. So in this example, user group devs is allowed to SSH into staging. We call this access path. And there are two other types of access paths in tag. There's a restricted path, which means that when found, it will restrict users to only have those matching actions allowed and nothing else, even if the other paths exist. Think of it as a security invariant that you want to enforce in the system. You don't control what other paths anyone else in your organization creates, but you control what you restrict everyone else to. So if your security team wants to enforce a strong security invariant that cannot be broken, that's what those paths are for. And finally, they're denied paths. Those are paths that, if found, they override everything else. And if you want to make sure that, for example, interns will never get access to production, that's what you write in the denied access paths. All those paths look exactly the same. The only difference is how they're interpreted based on their metadata. And remember, the big difference is tag always operates declaratively, not imperatively. It means that to determine access, tag aggregates all groups' paths before computing the outcome. It's a basically graph traversal process, right, with some evaluation on top of it. So rather than traversing them at the point each time when you need to make a decision, it actually keeps a interpretation of that to make those decisions effectively. And furthermore, another change from our traditional access control rules like scripting languages, tag recognizes time and context. For example, tag understands if this user is trying to evaluate this access path using a security device and what time in other parts of the context are participating in that context. For example, what time of day is this? And you can always go back in time and forward in time if you'd like to predict what will happen, because tag is time aware. Each of those things has metadata that responds, that has this from and to and expiration. So that's another thing that tag is different. This is another way tag is different. All right, so let me attempt a demo. I will zoom in, But first, let us go back to that first question. Remember, who has access to what and why? And we really, really want you to be able to answer this question exactly like I have done. So I've just answered that question for this user, Sasha, who has access to a couple of servers. Here they are. You can see there's Luna is a server, and there's another resource, which is SSH box somewhere. There's a little bit of a difference, though. You can see that Sasha is allowed to request access to Luna, but Sasha actually does not have access to Luna at this particular point. And then another important piece of that is asking a question, well, who can access Luna? Potentially, or at this particular moment in time. And again, you can see that I'm answering this question with one click of a mouse, because first of all, I don't like typing on live demos, right? It never really works well. But second, I had a challenge for our design team and engineering team for me to be able to answer this question holding a cup of coffee or tea in one hand and just clicking a mouse in another hand. And although I didn't hold, the challenge has been accomplished. Thank you, Ryan, for acing it. So that is the first foundational answer. Once you have everything in one place, once you build this descriptive enough system to help you to answer those questions, it is already pretty valuable. I wanted to show you a couple of, or attempt to show you a couple of other more advanced features. If we have time, let me check. We have eight more minutes, right? Okay. So let me zoom in into something a little bit more advanced. And the first one is, let's review the dynamic nature of tag. So I would like to request access to the server, to Luna, and I just created access request. And that's my other user. I'm going to log in. Review that request. Just going to approve it. Here, you would see now I have approved access request. And I can obviously assume those roles and access the infrastructure, but that's not what I wanted to review today. Today, if I go back to Sasha, you will see that there's a new access path that was created in the system. It's temporary access path. It will expire. So not only I was allowed to request access. So that's potential access path that exists in the system, and it helps you to understand who has potential access to the infrastructure, because that's as important as to have an instantiated access to the infrastructure. In addition to that, you can actually see who has access that has been granted as a basis of that access request. And with tag, you actually have ability to zoom in even further and understand that this specific access request was granted by a certain person all through tag, and those are their reviews. So it goes pretty detailed, covering everything that Teleport covers and other identity IAM systems like AWS IAM and GCP IAM systems as well. So that was the part of the demo that showed you the easy point and click way. We think it's really important because, again, you have 84 minutes, right, or less to respond. You don't have a lot of time. And it's also a very stressful situation when you think that there's potential breach. If you have ever been as part of incident response, you don't know what's happening. There's Slack room probably somewhere with folks joining and asking all those questions. There's business pressure. You cannot stop the servers, right? Because then it's going to be a PR disaster. You'll end up in the news. At the same time, you need to quickly act. And that's why we designed this first interface for those quick reaction investigation, reactive investigation, and make it very, very easy for you to identify all those potential access paths and lock those identities. Because once you understand what Sasha has access to, let's circle this back all the way to what we talked about. If we go to session identity locks, now it's really easy for me to go to all those servers and lock access to them to make sure that both Sasha has been locked out of the system temporarily while we're investigating, and the instances that he could potentially access because you don't know how long the breach has been happening, or can access right now, and you lock those systems out while you're investigating this incident. So let's go back to access graph. I'm gonna cancel this for a second. The last thing I wanted to show you folks today is a little bit more advanced flow for access graph. Behind the scenes, we are not obviously expecting everyone to be always happy with those advanced, those simple expressions or those interfaces that will never be enough. So we have built Postgres interface. Raise your hand, folks, if you know what OS query is. All right. So we tried to make it very, very simple for folks who know Postgres or SQL to be able to write their own queries. Although behind the scenes, it's a graph database. We've built our own front-end Postgres-compatible SQL language that helps you to write those queries. And you can also use help of new AI that will helpfully generate queries that never really work as well. However, in this specific case, this is more refined version of that. For example, show me what Sasha can review access to, because you need to also understand other side of the equation, who is reviewer for what? Who can potentially grant access? Because if you can grant access to many things, that's also part of your attack surface. You need to reduce that. Let's zoom in a little bit into other query. In this case, that's the version that we ran. And basically, it zooms in and says what Sasha can access or can request access to. Notice there's no protocol spec here. We ignore protocol. It could be an access through SSH, could be an access through app, it could be an access through database. Because if I have access to database and I can run certain types of queries, it's as good as me running exec on your infrastructure. And let's zoom in a little bit more and see what Sasha can actually access at this specific point in time, right? So here what you're seeing is those predicates that we have built that allow you to ask all those questions. Those are Postgres-compatible functions. We can build more functions that answer more detailed questions, but there is already several ones in the library that you can use. However, if we want to specify a certain protocol, we can do that too. So here I'm asking a question, show me everyone who can access any SSH server through any user at any time with any device. So you see a lot of any. We'll build named parameters to make it easier for you to type, but this will work for the initial MVP that we are rolling out, and I will follow up on that in a second. However, if we want to specify, tell me who can actually access as root or can potentially access as root, right? Remember, let's go to those predicates that give you that detail. Now, we narrowed it down just to Sasha. So you now see and understand your infrastructure a little bit better. And then you can actually make it a little bit more detailed. Let's see who can access infrastructure through SSH without device trust. In my case, because it's a demo environment, it's Sasha as well. But this will allow you to understand and maybe have discussion with the team that has a lot of access without using device trust or without using procession MFA. Folks, there's a lot of potential attack vectors here, right? Let's try to reduce those. I'm not going to probably run this one, to be honest with you, but this is more advanced. It will show you access request details. I'm not going to run it. I'm going to wrap because we just have 1 minute left for Q&A. Thank you, folks, for your attention, and let me know if you have any questions. So Great question. We haven't scripted this, by the way, but thank you for that question. We will release Tag to Teleport Cloud users first, starting with limited preview for team users in November, November 25th. That's what we're targeting. And it means that in a month from now, if you're curious, you can sign up for Teleport Team in our cloud. Just experiment with this in your staging or maybe dev environment. Then we will extend its availability to enterprise cloud customers by the end of the year. We'll try to extend it to enterprise customers by the end of the year, depending on your scale of the infrastructure. So reach out to us if you're interested to try Tag on premises or in AWS. And then we will try to reach to self-hosted customers on demand early next year. So you can try it by the end of the year, hopefully, on-prem. And early next year, we'll try to make it available for you in production or staging if you're on-prem. The reason for that is that we're using quite advanced graph databases to make this work, and they're not easy to deploy, right? And we want to give you good guidance, and we need to understand how they operate at scale first.
This is really, really exciting stuff. I have a quick question around securing the actual data in there and keeping the access and audit logs of who saw what. Because I think if a bad actor gets their hand on any of this, it's going to be the happiest day of their life because they can see every weak spot and every breach path in the system.
Yeah, it's a great question. I actually never thought about this before. But the good news about systems like this, Tag and any good access control system is self-governing, which means that you would use Tag. That's another piece that I haven't mentioned. We initially rolling out Tag in read-only mode, but we want to make Tag read-write by around middle of the year, which means that we want you to, over time, migrate off your IAM with JSON on AWS from other amazing access control systems that you're using and start using, including teleports are back, and start using Tag as a source of truth. When that happens, we want you to start using Tag to govern access to itself, which means all the same rule recursively apply to Tag. So you wouldn't like to limit attack surface to anyone who has read-only access to Tag. You might want to make sure they request access to certain parts of Tag when they need it. So all of those great rules, all of those rules apply to Tag as well, which means that it can control itself and prevent that type of problem from happening. Let me know, folks, when you want to wrap up.
Also, I have a question regarding the Tag in the we are using enterprise. We do have quarterly audit. So is it possible to run queries through API and dump JSON or export it?
Yeah. So one of the things we thought a lot about, we don't want you to learn a new programming language for writing access control because everyone probably already a little bit over the top with new programming languages. So that's why we went with Postgres. And it means that you can literally use Postgres queries to generate responses. And that's your first API. Another API will be available, Golang, Python, gRPC API. And you can script and program it as well. But in the simplest, the easiest way, just treat it as a Postgres database with magical predicates that answer certain questions, right? It means that you can run this once a quarter, export it to CSV, and that's it.
Thank you. Thank you.
We have time for one more question.
I think that's it. Thanks, folks. I really appreciate your time, and thank you very much for joining Teleport today.